Okay, today's lesson is 4.7a, the law of sines and the law of cosines, and we're going to solve triangles using these two laws. So the first one that we have is the law of sines, which y'all did talk about last year and the year before, so this part should be easy. But I want to refresh your memory in case you don't remember that in a triangle, the capital letters represent the angles, and the lowercase letters represent the side opposite each angle. Okay, so that's an important thing that you have to remember. And what the law of sines tells you that the sine of an angle over its side opposite is the same for all three pairs. Okay, sine of A over A, sine of B over B, sine of C over C. And one thing I'll wait till you get there. Sorry. Okay, one thing that's new this year is something called the ambiguous case. And that is, excuse me, if you are given two sides of a triangle and an angle that's not in between those two sides, okay, if the angle is acute, then you have multiple possibilities that could occur. You could either have no solution, you could have one solution, or you could have two solutions. But if your angle is right or obtuse, you can't have two solutions. You can only have no solution or one solution. So we're going to run across these as we're solving problems. Okay, and your law of cosines that I know you've talked about looks similar to the Pythagorean theorem, and it starts off with, you can use it with all different letters, so I'm kind of writing it with all the letters to show you the different ways it can happen. For example, if I started with a squared equals b squared plus c squared, similar to the Pythagorean theorem, minus 2bc cosine of a. Or if I started with b, it would be b squared equals a squared plus c squared minus 2ac cosine b. Or if I started with c squared, it would be c squared equals a squared plus b squared minus 2bc cosine of c, 2ab cosine of c. Now, the most important thing you got to remember is that this angle is opposite that side. So whatever angle is over here needs to be opposite that. Okay? And law of cosines, I find it easiest to remember that you use the law of cosines when you don't have a pair, like we did in the law of sines. Some people like to remember that it's when you have two sides and the angle in between, or three sides. All right, so let's go look at our problems. The first one that we have says, solve the triangle, round to the nearest tenth if necessary. So if you remember, when we talked about solving triangles, that means we have to find all of the missing parts. So first off, I'm going to look at this and say, what do I need to find? And I need to find angle H. And then I also need to find side F and side G. Okay, so then I look at my triangle and I'm looking to see, do I have a pair? Do I know an angle and a side that are opposite each other? Well, it doesn't look like it from your picture, but the fact that they gave me two angles of the triangle means I can always find the third, because I'm going to take 180 and I'm going to subtract what those two add up to. And when I do that, I'm going to get 15 degrees. So now I have a pair, and since I have a pair, I can now use the law of sines to solve my triangle. So I have big H, which is 15, and I have the side opposite, which is 18. Now, I'm going to tell you, when I do this, and I'm showing you how to try to make this very simple for you to set up, okay, I always put the one that I know in the middle, okay? And the other thing that I want to point out to you, okay, this is what the law of sines says, but our property of proportions tells us that I can flip this and say A over the sine of A, B over the sine of B, and C over the sine of C. If you can remember that, I'm going to show you how to make solving these things pretty easy. Okay, so what I do first off is I put the one that I know in the middle, and since what I have left to find are my letters F and G, those are the ones I'm going to put on top. So I'm going to put my sides on top and my angles on the bottom. So I'm going to put 18 on top. Oh, I didn't want to do that. Come on, try that again. All right, one more time. 18 on the top and sine of 15 on the bottom. Okay, and it doesn't matter which one you put where. I'm going to put F over here, and what's opposite F is 53 degrees. So I'm going to have the sine of 53. And then what I have left over here is G, and underneath it is going to be the sine of 112 because it's opposite. Okay. Now, if you can set it up like this, what I'm looking for, you're going to take just two ratios. So I'm going to take these two to begin with, and I'm going to solve it for f. So to solve it for f, all I have to do is multiply by the sine of 53, which in essence moves it to there. So that means that f equals, what's on top is 18 times the sine of 53, and what's on bottom is the sine of 15. And so when I put that in my handy dandy calculator, and y'all use that horizontal fraction bar, if you do not have a horizontal fraction bar, you got to put parentheses around that numerator. Okay. So class calc, okay, that's why I really push it here, because you start off by putting in that division symbol, and then you type in the top, and then go to the bottom and type in the bottom. And when you do, you should get an answer of, rounding to the nearest tenth, 55.5. Okay. Now, I've already got it set up, y'all. I'm looking for G. So this time I'm going to use this side of my extended proportion. Okay. And if I'm solving for G, I'm going to multiply both sides by the sine of 112. So I'm going to put it over there. So I'm going to have G equal to what's on top, 18 times the sine of 112. And what's on bottom is the sine of 15. And so G is equal to 64.5. And that's all you got for that. Okay. Pause one sec. Okay, next. Find all solutions for the given triangle if possible. If no solution exists, write no solution. Round side lengths to the nearest tenth and angle measures to the nearest degree. Okay, so I have A is equal to 5, B is equal to 6, and big A is equal to 63. So again, first thing I'm going to look for is, do I have a pair? Okay, I do have a pair. And since I have a pair, I get to use the law of sines. Although I probably should have said, what do I need to find? So what do I need to find? If they give me big A, I don't have big B, and I don't have big C, and I don't have little c. So that's what I have to go find. All right. So we have our pair, and now I'm going to go write my extended proportion. Okay. And the one I'm going to put in the middle is the one I know. And what I'm looking for first, because I have a pair of A's, big A, little a, and I have little b, then I'm going to go find big B first. And so since I'm looking for an angle, I'm going to put that angle on top that I know, which is the sine of 63. Underneath it would be 5. And then again, it doesn't matter which side. I just chose to put sine of B here. Underneath is going to be 6. Over here, I'm going to have the sine of C and C. And again, I just write it all so that I can see it well, okay? So I'm going to use this first two ratios on the left side, these two here together. And remember, since I started and put my angle on top, all I have to do is multiply by 6, which in essence moves the 6 over here. So that means that the sine of B equals, what do I have on top? 6 times the sine of 63. And on bottom, I have a 5. Now, this is an example that I'm looking for the angle. And since I'm looking for the angle, that means I'm using that button on the calculator that requires the second. So it's the inverse sine of what I just wrote up there. So when you put that in your calculator, and I encourage you to do so, you might get something that looks like that, domain error. Now, if you aren't sure about what you've done, of course, you can look at what you wrote. But if you were to go just calculate the inside here, you'd find out that that's equal to 1.069. And you can't, the sign can never be larger than 1. So if it's ever more than 1, then that means you're going to have a domain error if you try to take the inverse sine of it. And in essence, we have no solution here. So you can use a symbol, or you can write out the words no solution. Okay? Next, find two triangles with the given, oh, they told us we have two triangles. Okay, so if they told me that I have two triangles, then I'm probably going to go set up my two triangles. Okay, that's my case. This is how I'm going to work this. So round the side lengths to the nearest tenth and angle measures to the nearest degree. So again, I'm looking at it, and do I have a pair? I do. I have big A and little a. So I have a pair, which means I can use the law of sines. And now I'm going to go say, what do I need to find? So just like we did before, I have big A, I need big B, I need big C and little c. Okay, and I'm going to set up my extended proportion. And what am I going to have in the middle of the two that match? And again, I'm going for the angle first. So since I'm going for the angle, I'm going to put it on top. So I'm going to put what I know. So I'm going to have the sine of A over sine of 26 over 5. And then I'm going to have the sine of B over B, which is 9. And then over here, I've got the sine of C and C because I don't know either one of those. Okay, starting off with this ratio, this proportion, those two ratios. Again, solve over B. Since I put it up top, all I have to do is move that 9. And so the sine of B is equal to 9 sine 26 over 5. I'm looking for the angle, so I've got that inverse sine of that fraction there. And when you put that in your calculator, you're going to get B is equal to 52 degrees. Okay, this is the hardest part. Okay, so I'm going to go put 52 degrees right there. Okay, now the thing that I'm going to explain this once. You don't have to, I'm not going to do it every time, but some people want to understand why this is the case. Okay, but when the sine is 52 degrees, that is not what I wanted. That angle right there is 52 degrees. But there's also an angle over here that is 52 degrees that is really 50, has to be measured with that dotted orange line. So we take 180 and we subtract it from 52, which I wrote over here also. So that other angle is 128. So B is either 52 or 128. Now, once you find that, y'all, what you want to do is basically you want to cover up one of these. So I'm going to cover it up just like that, okay? Because I'm going to go finish solving the first triangle, and then I'm going to go talk about solving the second triangle. So in the first triangle, I now am going to use the right side of my extended ratio, and I'm going to have this 5 over the sine of 26. Now this time, remember, before I finish, what is angle C, y'all? Angle C, if I know that A is 26 and B is 52, then I know that 180 minus 52 minus 26 is going to give me 102. So that means all I'm looking for left to solve in this triangle is the C, big C. So that's why I switched it this time and put the number on top. So 5 over the sine of 26 equals C over the sine of 102. Okay? Again, I'm solving for C. I'm just going to move that guy up top. So C is equal to 5 times the sine of 102 over the sine of 26. And when you punch that in your calculator, you're going to get 11.2. Okay? Now, I'm done with one triangle. So now I want to go do the other triangle. And you really want to cover this one up because the only time you ever you need to see both triangles is when you find that first angle. Okay, so I'm going to use this same thing here to find it. Okay, if I knew that this was 128, okay, and I know that this is 26, then that means that the last angle that I have to find is going to be 180 minus 128 minus 26, which is 26. So now I'm going to use this same thing, but I'm going to substitute instead of 102, I'm going to use 26. So I'm going to have 5 over sine of 26 equals C over the sine of 26. Okay, some of y'all might see this, but just in case, I can multiply both sides by the sine of 26, which moves it up there. And C is equal to 5 times the sine of 26 over the sine of 26, which, yes, those are the same thing. So my answer is going to be 5. So this is what your two triangles look like. Okay? All right, real quick, just I'm getting real close. We got 2 more, y'all. All right, solve each triangle, round side lengths to the nearest tenth, angle measures to the nearest degree. You can see a pattern, hopefully. So we have triangle XYZ, and they've given me X equals 5, Y equals 18, and Z equals 14. Okay, I do not have a pair, and since I do not have a pair, I have to use the law of cosines. This is the case of side, side, side. Okay. Now, when you do this, I would encourage you, so that you don't make mistakes, to always start by finding the biggest side first, okay? before we go on with that, clearly if they gave me all the sides, I have to go find all the angles. So I have angle X, angle Y, and angle Z that we're going to go find. But we're going to find the biggest side first. Find the biggest side. Use the biggest side is really what I meant to say. Find the biggest angle. The biggest angle is opposite the longest side. So the longest side is 18. Okay, so that means I'm actually going to go find angle Y first. Now, I'm going to write this using that law of cosines. Okay, if I'm looking for angle Y, then it's going to be y squared equals x squared plus z squared minus 2xz cosine of y. Okay, because, and remember, these two are the ones that have to be opposite each other. Okay, and that's the one I'm looking at. If that's the angle I'm looking for, then this is the side that has to be opposite. So y, of course, is 18. X is 5, Z is 14, and then I'll plug them in. Okay, now this is the key where a lot of people mess up, so please pay attention here. Okay, when you're solving, okay, I have to get rid of this and this to get the y by itself. Okay, you cannot combine all of this. That's what people do to mess up. You cannot combine them. So I have to take this first one. First thing you want to do is take that to the other side. Okay, and how do you do that? Well, you're going to subtract them. And then the second thing you're going to do is that part. So it's going to look like this. I'm going to have the cosine of y, and I'm going to have 18 squared minus 5 squared minus 14 squared. And then I'm going to divide by that other thing. And I kind of want you to put it in like that because, y'all, the less you have to pick up a calculator, the less often you're going to make a mistake. So if you can get that in there, and again, really easy with class calc because you get to put it in there just like that, or some of your other calculators with the horizontal fraction bar. So when I put that in a class calc, it gave me a fraction. I just left it like that. And I'm going to do y is equal to the inverse cosine of that fraction. And I get that equals y equals 137.36, and I'm supposed to round to the nearest degree. So that, of course, is 137. Okay. Now, at this point, I'm going to use the law of sines. Okay. And I'm using the law of sines, and I'm looking for an angle. So I'm going to put the angle on top. Okay. What do I know? I know the sine of 137 over what's opposite 137 was 18. And what am I going to go for? It doesn't matter. I'm going to say the sine of x is over x, which is 5. Okay. But the variable that I'm looking for is on top, so I'm going to move my 5 in front and know that I'm looking for the angle. So x equals the inverse sine of 5 sine 137 over 18. And you can put that in class calc just like that. So you don't even have to have this intermediate step if you don't want to. Okay, you can have it just like this, and you punch it in, and you're going to find out that x is equal to 10.92, which rounds to the nearest degree of x equals 11 degrees. And then to find the last angle, y'all, we always want to just subtract from 180. So I'm going to have 180, and I'm going to subtract 137, and then I'm going to subtract 11 and get an answer of 32. Okay, one last problem, and then we are done. And it's one of the easier ones, so that's a good thing. All right, so same thing. We're solving the triangle JKL if J is 125, K is 24, and L is 33. Okay, I've got JKL. That means I do not have a pair, so I have to use the law of cosines. This is an example of side angle side. Okay, and so I can go and say that I'm looking for J, segment J. I'm looking for angle K and angle L. Okay, and I'm going to go ahead and find, well, I'm going to write it. So I've got J squared. People just tend to make fewer mistakes, y'all, if you go ahead and take the time to write it. So J squared equals K squared plus L squared minus 2KL cosine J. And remember, this angle is opposite that side. Okay, J is what I'm looking for. Okay, K is 24, L is 33, and big J is 125. Now, I encourage people to write this step because they forget when they put that in the calculator that they actually have to take the square root of it. So when you take the square root of that, you get 50.7, okay, because we're rounding to the nearest tenth, okay? And now you can use the law of cosines again, y'all, but law of sines is a little bit easier. So once you use the law of cosines one time, then most people switch over. I'm looking for an angle, so I'm going to have that angle on top, and I'm going to have sine of k is over, what's little k, 24, equal to what I know, which is the sine of 125 over what I just found. And I decided not to round. You technically shouldn't round the things. My answer's rounded that way, but I shouldn't round it when I use it in other parts of the problem. But I'm solving for k, means I just have to get rid of this bottom number of my multiplying, so I move it up top. And I'm looking for the angle, so I'm going to have k is equal to the inverse sine. On top is 24 sine of 125. On bottom is 50.703. So k equals 22.8011, and I'm rounding that to the nearest degree. So k is 23 degrees. And again, third angle, because I already know two of them, I'm going to subtract from 180. So I'm going to have 180 minus 125 minus 23, and that is equal to 32. And that is all you have for the law of sines and the law of cosines. Thank you so much. Y'all have a great day. Please don't hesitate to email or contact us if you have any questions. Thank you.